I would like to introduce our keynote speaker, Jennifer Case. She's a professor and head at the Department of Engineering Education at Virginia Tech. And this is something that the US is pioneering, having engineering education departments. I believe Virginia Tech was either the first or one of the first. First? Wow. Okay, so yes. That's great having her here. And if someone is a professor of engineering education, you might wonder, okay, and so what did they study really to be now professors of engineering education? Jennifer Case, she's a chemical engineer. So before that, she was a professor of chemical engineering at the University of Cape Town, where she has still a honorary appointment. And she's very international. Her postgraduate studies she did in the UK, in the Australia, and South Africa. Her research focuses on student learning and curricular reform. She has many publications. I invite you to search her and read it a little bit. That's how we discovered it. Margarida Pino Lopes heard a talk she gave in, two talks she gave in Portugal, I don't know how many years ago. And so, yes, ... So she is, I find this very interesting. She's a founding member of the Center of Engineering Education in South Africa, and also the founding president of the South African Society for Engineering Education. You see, we are a boutique conference here, and we got more than 6 abstracts from South Africa. You'll hear quite a few, several papers from South Africa. So something is happening in some countries in the world. US is one, Portugal is another, South Africa. So somehow we have to connect to these places that they're further ahead with what is going on. So I'll close with a personal note. Jennifer Case accepted our invitation on December 12, 2024. That was 203 days ago, and I'm excited for 203 days now to hear Jennifer Case giving us her keynote. Jenny?
Thank you, Marina. Just quickly, sound check at the back. Is this sort of how you want it to be running? Well, the audience looks okay. I know they're filming as well. Thank you for such a lovely introduction and for that email I got most probably on the 11th of December. And it's such an honor to be invited to come to a conference like this, as you say, a boutique conference of people who care about teaching in geotechnical engineering and curriculum. We'll talk about that in a moment. A very special thing about that email from Marina, she wrote to say, I've just read this paper of yours and I really like it and I want you to come and speak here. So it had a real substance to it, the invitation. And then we have had a few conversations over these 6 months around what should be the substance of the talk. Well, let's see, you be the judge, but I've appreciated all the support also in crafting what I'm doing. And it's such an honor to be here and to be here at the school as well. Thank you. So my topic today, I have titled Urgent Questions for Engineering Education in the Age of Generative AI. And the questions I'm going to pose are maybe not the questions that are catching the headlines around AI, but my argument here is going to be that these are actually the crucial questions for us who teach engineering and who teach engineering in specific disciplines, in this case, geotechnical engineering. And I think it is a moment where we need to revisit some of our thinking around knowledge, teaching, and assessment. So let's get started. And I've crafted here what I've called a checking-in exercise. I'm going to play a very short video clip. It's just over a minute. Then you're going to get to the person next to you and answer some questions, or give your opinions more to the point. So let's just get this guy going. Okay. Okay, that's the end of my clip. We will stop there. One can ask more questions on that. And I'm just going to get on. So, get with the person next to you. You might have to scoot along, find a partner. This is more fun to do if you discuss with someone else. One of you just needs to click with your camera on the QR code. It should get you directly into a poll. And check which statements you agree with. You can click as many as you like. You're welcome to discuss with the person next to you, and it shouldn't take about a minute just to see what do you agree with. If you disagree with something, then don't check it. Get chatting. You can choose as many as you want. Everything you agree with, you choose. Anything you disagree with, you don't choose. Who's done? Who's already finished? Who needs more time? Okay, we just give you a few more seconds. Oh, you can choose as many. Okay, I'm sorry, the poll has reset itself. You have to choose your most favorite item. That's annoying. Okay, this is going to allow you, if you still click in, it will let us see your, and I apologize that it's only allowing one, your most favorite statement. Let's just let it settle down a bit. Is this what you expected? Right, okay, this is very interesting. I didn't really know how this poll would come out, but it gives you a nice flavor of the room here. I want to say this is a bold, courageous, innovative community that cares about student learning. That's also realistic. I'm actually encouraged by the green bar at the top, because I do think it's a highly interactive textbook. There are opportunities for learning, for resources. There are fears, so students are just going to get past it. But that is what I just said, oh my gosh, that is not dominating the conversation in this room. So I think this is a very good starting point for what I want to do today. So let's move on then. So I think we all agree the age of generative AI is with us. I mean, that little clip of playing with ChatGPT, who is highly familiar with that tool? Anyone, you've seen it a lot, okay, who was very surprised by what they saw? A little bit surprised, maybe, okay. And of course, by the way, a disclaimer right at the start, I am not a geotechnical engineer. I know very little about the topic. I know a little bit more because of... So some preparation, and it actually surprised me. That was one of many questions I put to it, and I was a little bit wow myself, even though I have played with that tool. So there is a lot of research that is showing already that students are using these tools, unless they're prohibited from doing so, and they are familiar with how to use them, by the way. They're very easy to use. Some faculty, academics, are using these tools as well in preparing their lectures and their exams, and that's quite controversial. I think one of those articles there, by the way, we will share the slides, of course. And there's also a link, I think my third link there is that engineers are using these, and other professionals are using these tools. Exactly how they're using them, I'm finding there's actually not a lot of research that I'm getting clarity on yet. So, but most definitely for fairly transactional tasks, they are very much used. So there is a buzz, but I also want us to not be naive about what is driving this buzz. There's potentially a lot of money to be made with this new technology, but the business model for how to make that money is not yet fully established. A lot of investment money has flowed into these technologies. In terms of universities, there is definitely a business push to get these tools into all universities, and that New York Times article references that. So one can think of the kind of licensing models that we are already subject to with Microsoft, Google. In engineering, MATLAB, someone was reminding me that MATLAB did a particular coup to get into universities so early on. So there are parties other than university people who are driving a certain rhetoric, and I think we should not be naive in just taking that on board. We need to think about what we do as educators, and that's really what I'm going to try and do in this talk. So just briefly, one or two things to notice about these tools, and here's a quote I found really helpful by my colleague Aditya Johri from George Mason University in the US. And he notes, and as you saw just from that clip, it's very easy for students to incorporate genAI use into their learning practices. He does put quotes around learning, compared to faculty. The adoption by students is much higher, and Aditya is one of a number of people who've done this research. Reflective use is not absent, but it's not the norm. Here's the part I find very significant. Why ChatGPT has succeeded is because it leveraged a mental model that young people are familiar with, a conversational exchange of information. And I do think that is a particularly significant feature of these tools. So the large language model definitely allows for this human-like conversation. And yes, the clip I showed you earlier, I went on then to say, hey, ChatGPT, I don't really understand affective stress, but I think it's really important, help me. Why is that symbol underneath the line? Why did you add this thing on? And getting these kind of responses. For the calculations that you saw in that clip, and I'm not an expert on this, but these tools are not only using language models to give their outputs, they are also calling on external programs, whether in Python or some other tool that can do the calculations. There are a lot of our standard equations that are all plugged in and ready to go. The package together does make these quite compelling tools. So now, to firm up the focus for this talk, and I first want to say what this talk is not. And sorry if this is what you now were hoping it's going to be. This talk is not about how to use genAI in your classroom. So there are a lot of talks out there, there's a lot of articles, there are a lot of people experimenting with various things. And I don't want to say that's not a good thing to do, but I feel like there are deeper questions that I'm feeling we need to talk about, and that's the focus for today. So I think this is a tech disruption. It's not the first, and I'm looking across, there are people here who are my age, a little bit old, a little bit younger. If we just compare to the tools that are available when we were undergraduate students, we have lived through waves of very interesting disruption. Simply the availability of information through the internet is still, I think, one of the most significant things we have seen. I don't know if you remember, I remember the first time when I was lecturing, and you put out a question to sort of get everybody thinking, and a student held up their phone and gave an answer from searching the internet on the phone. I remember that moment. I remember the very lecture theatre. I remember thinking, oh my, we're in a new phase. Yeah. So I think there are important questions. Let me get on with it because I've said that a few times. But crucially, I don't think you can find the answer for these questions from within the tools itself, from within the technology itself. And this is something, as engineering educators, this has always been a risk because as engineers, we do get excited by the technology. And I'm very sure that we will have at this conference as well some talks that just stretch out what can we do with these technologies. But the educational questions are educational questions. And that quote by Hodges and Kirshner I find particularly useful. So to go into the education foundations, I've got questions, some of which might seem familiar, but some of the answers might change. We also might need to see if there are new questions to ask and maybe new answers. So I want to put a risk. Stopping to say there are a few important questions we should ask doesn't always make you popular because people go, oh, you're not enthusiastic enough and you seem like old-fashioned or something. But I think there are risks if we don't do this. So what are these questions? So first question, what do students need to know? And this is a very prominent question now in this age, what I call the age of generative AI, where, as I already said, not only is information widely available through the internet, very different to, as I said, most of our undergraduate studies when we were in the university, but now we also have these tools that can quickly produce seemingly human-like outputs. So what is knowledge? What does it mean to be knowledgeable? Is there a difference between knowledge and information? Because there are certainly people who would say, well, we don't really need university because everybody can just get any information they need on the internet. That's a position we need to interrogate. So I think we're living in times where knowledge is easily dismissed, but it's arguably more important than ever. So that's the first question, which is a curriculum question. What do students need to know? The next question, what is the role of the teacher? So again, some of the rhetoric we have coming from the tech industry promises us a teacher-free future, which might be attractive for policymakers, entrepreneurs, certainly, because teachers are expensive. Teachers, academics, faculty, whatever word you want to use. Now, this is also not a new argument. Certainly from the introduction of televisions, there was an argument that we wouldn't need teachers anymore because we would just put students in front of televisions and they could have the best lecturers in the world rather than just the regular folks at their local university. Yeah, I think we need to take that question and use it to think about what is the value of teaching by a human as opposed to a tool. And then a third question that's quite prominent presently, how do we assess that learning has happened? We are professionally bound to be able to say, this student has demonstrated knowledge and skills that they need to be a geotechnical engineer. How do we need to change how we think about assessment now that we have these tools? What do we do there? So certainly there's a lot of headlines about the potential for cheating with the help of generative AI tools. There's some focus on AI detection. It seems fairly clear that might not be the solution. We've got to actually think about assessment. So this is the talk. I'm calling these the knowledge question, the teaching question, and the assessment question. So let's get on with those three questions. The knowledge question, I want to kick off to share some work from a study we did about a decade ago, and the graduates we interviewed then were about a decade out from their degrees. So they had been working for about 10 years. It was a part of a bigger study. And we asked them a question, this is not a new question, other people have asked, what did you really get? What are the most important things you learned during your time? And this study was actually based on there are quite a few chemical engineering students in this study. Now, even just popularly, you will know, people say, I didn't use anything I learned in my degrees. and you do notice, oh, here's the answer. So this is what they said. Confidence to tackle problems, an engineering approach to problem solving, working independently, ability to learn new knowledge. And these are very typical answers that your graduates will give. And of course you think, oh my word, they didn't say reactor design. They didn't even say mass and energy balances, which I taught them. So maybe the knowledge is unimportant. And this is a really risky misunderstanding, in my view, of these kinds of comments. Because if you read this, it looks like they only get generic skills, generic content-free skills. And some people might look at this and say, fantastic, we just need a degree that teaches how to solve problems, teaches lifelong learning, teaches independent learning. And here is a really crucial piece on this matter, and you'll see it coming through the talk again. You cannot learn skills, advanced skills, separate from knowledge. They cannot be learned context-free. There's also not just a course on problem solving. I know we often use those words to explain, but I will say even the problem solving that a geotechnical engineer does is different to the problem solving of a chemical engineer, because the context is different. So this enthusiasm for generic skills is possibly one of the worst mistakes of progressive education reformers in the 20th century. People have played this game across schooling, across universities a bit less, but it doesn't work. And really now there's a lot more people who are saying this was a bad mistake. Knowledge matters. So saying sort of the same thing but with different language, and thanks Marina, you said this was the slide you liked most in my draft talk, so I kept it. I got rid of the things you said you didn't like. No, that's just a joke between us two. So I want to say you can't reverse engineer from workplace practice back to formal curriculum. It's another way of saying what I said in the previous slide. So here's someone in the workplace, and I argue you can't say, that's what they do in the workplace, so therefore this is what the curriculum must look like. Of course, we need to know what are our students doing in the workplace, and we want to see that they're productive, but you can't analyze the skills in the workplace and then build up your curriculum that way. You have to build up your curriculum from disciplinary knowledge. So another point is really to also distinguish between, like there's a formal curriculum, it's a civil engineering curriculum. There's some things that look familiar or not familiar. I know we're going to talk a lot about numerical methods in this conference, it's in there. I want to make a distinction, though, to on-the-job training. So certainly when you start your work at a big, construction company, they will need to teach you quite a lot of things that are specific to that company. Maybe some of the software, some of the safety practices, a whole lot of things. And sometimes those certificates can be quite elaborate. That is really important. People do learn on the job, and professionals have to learn on the job. But that is different to the learning that happens in what I'm calling formal education during a degree. So, and to sort of further try and illustrate that, I was thinking about Excel. So I'm going, maybe this is 20 years back or so, but I remember in chemical engineering, University of Cape Town, the Excel moment was where we were like, all engineers use Excel. Our students sort of use Excel, but not really well. We were at that point focusing much more on getting them into MATLAB in first year. And there was this moment of we need to do more Excel-based problems, which we did. And it was great, and this is all important and so on. But my point would be, we didn't say the curriculum exists to teach our students how to use Excel, because that would not have been a chemical engineering degree. It was built into the curriculum, which also had some very distinct foci, but we made sure that we were building up some of those skills as we went along on particular tools. But I just don't think you can have a curriculum, you can't use this thing. And actually at that point, if you looked at what engineers, like across the board, what tools does everyone use? I mean, Microsoft Excel was a big deal then. So, to try and summarize what I've been saying is you can't avoid knowledge. And certainly there are people, there's a few references here of the papers that have very much, to me, said this better than I can. So just to recap, being able to access information is not the same as being able to understand that information. And that's that question earlier on, like, do we need universities? Because everybody can just look up everything on the internet, and then they can feed it through ChatGPT. In fact, they don't even look it up on the internet. Look it up on ChatGPT and do something with it. I think this is a key issue for professionals. Professionals need to make critical judgments that are grounded in deep understanding, and these are highly consequential judgments. And I suppose the nice thing about teaching chemical engineering students, we would always talk about, you're the person that signs off that the reactor is not going to explode. You tell your students, I'm sure, you are the people who are going to sign off that this foundation is adequate for the safety of this building, and things aren't going to collapse, or there's not going to be a landslide or something. So there's my point about professionals, and I think, just in case you didn't hear me, there really is limited value in a generic skills course. A course on problem solving or a course on lifelong learning. You learn those things through learning the discipline. So now what is, for me, really, really exciting about being at this conference is the hard question is, how do you do this? And this is now becomes very discipline specific. You need to identify what are the main concepts that we need to get students to understand. And there are a couple of different theories you can go about this, but I think the idea of threshold concepts is a really useful one. Some people might say the big ideas in your discipline. Threshold concepts was put forward by Ray Land and Eric Mayer in the early 2000s. I realized I was at the conference where they presented their first paper with this idea of threshold concepts, which in those nearly 25 years since then has been a very useful framing for many people. What do they say a threshold concept is? It's a concept which cannot easily be assimilated or accommodated within one's existing meaning frame. It's new knowledge that is troubling, and you have to have not only reconceptualization, but you have to reformulate how you see the world. And I think this is a real heart of what we do. Now, I was then delighted to think, has anyone done research on this in geotechnical engineering? And voila, Marina presented a paper in 2020 at this conference proposing that effective stress is a key concept at the foundational level in your discipline. And as I said, I could test this out because I'm not a geotechnical engineer. And I can say from my little experience, this is a very non-intuitive idea that, you know, the forces between the particles is what we need to worry about, and we take the water out of the equation. You can explain that better than I can, but I've gone back and forth. That's why would you do the calculation that way if you were trying to figure out? And I've done a bit of physics in my time, but this is a very specific approach to thinking about the physical world that you need to get your head around if you're going to be a geotechnical engineer. And then going on into the program for the conference we're at today, I was very excited to see this paper, which is developing concept inventories for geotechnical engineering from these colleagues at 2 German and 1 Austrian universities. This was a very, very interesting and well-written paper. So they developed a suite of multiple choice questions to test students' understanding of key concepts, including effective stress. And then they also did this classroom exercise where they got students to answer the question, then talk with each other and answer the question again. So I want to show you 2 questions in their inventory and just give you, I'm going to give you 15 seconds to just quickly look at them. 2.2 and question 3.1. Have a quick look. Oh, the right answers are in green, very helpfully, thank you. So I want to ask you the following question. Which of those 2 questions do you think is best for testing conceptual understanding? They both are related to similar ideas, so they're not exactly the same idea. Which one do you think tests conceptual understanding best? Do you want to talk to the person next to you for 15 seconds? Which one? The left or the right? We can call them the left and the right. So who thinks the question on the left is the best for testing conceptual understanding? Put your hand up. Let's just get a... Which one do you think is best for testing conceptual understanding? The one on the left? Who wants to argue for that? Okay, and who thinks the one on the right? Okay, does the person who said the left, I don't want to put you on the spot. Do you want to say why you picked the one on the left? Okay, so it's more complex, if I'm understanding what you're saying. I don't know if I heard you. Yeah. And the people overwhelmingly went for the one on the right. Does someone want to say, why do you think that one is better for testing conceptual understanding? Someone want to? Yeah. So this we're going to get onto in the assessment question as well. I would agree. I'm not saying that's not an important question as well, but I've certainly seen this in my own research and in my own teaching. When you ask people to explain something in words and you can't put numbers into equation, that often does force you to be able to access conceptual understanding. Thank you. One small point, this is a coffee conversation with the authors that I hope to meet. And I was also looking at the 2016 keynote lecture by the eminent Atkins in your field. I think that's a much quoted lecture. And I can see we tend to use the word skills often for what I'm calling concepts. And look at one thing about a lot of education research, you can sort of pick the different theoretical approaches. Sometimes there's different terminology. I prefer to keep the word concepts in there, because then I think we are very clear about conceptual understanding. But I do appreciate we've gone a bit towards skills, because we all do outcomes-based accreditation, and we have to say, what can the student do? So we almost think of understanding as a skill. But these are things one can chat about. Substantially, I think this work is really useful. So moving on then to my second question is the teaching question. So firstly, what is the knowledge questions? What do students need to know? And exciting to see there's work in this conference already about what are the concepts, how are we testing them. So how do we ensure that students really do come to understand the core knowledge? And we said that it's not easy to learn threshold concepts. And I think that's really, for me, the problem with this, I'm going to call it, a tech utopian rhetoric. This teacher-free idea, because students can just watch things on the computer and learn. Learning scientific concepts is really hard. And this was a major finding of the then emerging field of science education research back in the 1980s. And that's really where I started my research career, working with, when I did my master's, with folks in the UK who were doing that research. The key finding is students can pass exams, but not necessarily understand the core concepts, and we even know that personally. So here is a research study back in the 80s that sent out shockwaves. I'm going to just play a little bit of a clip, sorry, there's no sound, but we actually don't need the sound, so let's just get it playing, which means it won't interrupt with. So as you can see, there's a tiny little bit of noise coming through my computer. It's at the Harvard commencement, Harvard University. And what the researchers did was they interviewed Harvard graduates on the special day of their, what they call commencement, or would call graduation. And they asked these students some very basic questions, scientific questions, the sort of questions that you're supposed to be able to answer if you did middle school. The video is called A Private Universe. Let me just advance us a little bit on. So for example, here's a student and they're asking them, why is it warmer in summer and colder in winter? And okay, here this is the private universe. Many of these students, so I only gave you one of them. There's a whole bunch of them. We can just pay one more back here, but there's the, what are they saying? And these are students with advanced degrees in science, some of them in astronomy. They say, well, the Earth goes around the sun, and during summer, the Earth is closer to the sun, and during winter, the Earth is further away from the sun. And as I say, it does feel like a bit of a 1980s video, because I'm like, oh, we would never put our research subjects on a video and then blast it out to the world. But there it is, and maybe no one has objected. I'm sure they've all gone on to good careers despite those misconceptions. So the takeaway from this is that teaching for conceptual understanding is really hard. There's one of the best universities in the world, and students struggle to grasp concepts. Here's the study that I then focused on in my PhD, because I thought this was really interesting. How do you support students to learn difficult concepts? And at that point, I was at the University of Cape Town in chemical engineering, and I was following a set of students through, and that's this small set of students, but in detail through the second year of chemical engineering. The lecturer there had a very strong focus on conceptual understanding. I was also documenting and tracking the teaching, and I'd moved then from saying what are their misconceptions to saying what is underlying the fact that students are not grabbing the concepts. And this is a theory called approaches to learning, which you may or may not have heard of. And there is, on the left, a surface approach to learning, which does not involve understanding. And on the right, what is called a deep approach to learning, that is focused on understanding the concept. In the middle, in this study, we've used the word procedural approach. It can also be called strategic. You know the procedures, you know how to solve these problems, you can pass the exam, but you don't necessarily engage too much with the deep approach. In this course, the lecturer made it really clear you have to get the concepts. The teaching was oriented that way, so was the assessment. So what did I see? Following these students through the semester in multiple forms of data collection, there's a group who were using the procedural approach who did actually make some shifts through this semester in this intensive course, which is what we wanted to see. Only one of them, though, made what I determined it to be an early shift that went all the way to a deep approach. Those next three were sort of wavering and getting there. Sorry, those arrows obviously aren't quantitative, they're just illustrative. It was maybe not surprising, but also hard to see that that really did correlate with who passed the course, who failed the course. And obviously there's more stories down there. I did further follow-up work with these and other students. But, so, this is where teaching comes in. Because how do we help students not only grasp a threshold concept, but overall shift their learning to make sure they understand these concepts? And this is, I think, the really core answer in relation to why I don't think a chatbot can do that. So I asked here, you know, what does teaching have over an AI agent? And I think it's the human relational side of things. The central question for me is, are we leveraging this? So if we're just standing in front of the class, mumbling away and flipping through the slides, giving students nothing different to what they could just get, maybe they could get even better on Khan Academy, then why does society support this expensive thing of university education? We have to be doing something in the classroom that creates a human connection, and obviously not only in the classroom, but beyond. So this is another study that we've done much more recently about lectures. And so we wanted to respond to this popular idea that lectures are bad and we should get rid of them, everything should be flipped, it should be small groups, etc., etc. This was the interesting thing with these second-year engineering students, and this was now across a number of different institutions. They said, oh yes, we do value lectures, and this is what is important. This is why we go to lectures, and this is why we think some lecturers are particularly good. This, again, is sort of partly not surprising, but also valuable to hear. They spoke a lot about explanations of difficult concepts. They talked also, though, about interaction, someone I can ask questions of. They did acknowledge when someone was doing something really what we might call active learning. And then this third thing that I also think is really key is the lecture was like a link into their private studying. Tips on what to focus on studying. Tips on where to get tools. Tips on where to find good resources. Here's a quote just to give you a flavor of this kind of work. The student said, the ones I like, i.e. the lecturers I like, is when they do it on the board. They use chalk. As they go in through the lectures, it's generally slower because they have to keep up with themselves. They can't just flip through the slides. There's an entirely different keynote that I'm definitely going to give someday, which rails against PowerPoint. Obviously, I'm using PowerPoint here, but PowerPoint for teaching engineering, I think has had bad consequences for a lot of what happens. So there we go. At this point, the final question I've got for you, the big hairy education question of assessment. And definitely that's what everybody is thinking about in this moment. So why do we... A real question is what in the US they call homework assignments or take-home exams. What do we do now when we used to say, please go and work this out at home and then we'll grade it or we'll give you marks for it, when actually this could just be done by ChatGPT? So I think the key thing is this is not entirely new. So students have always been able to bypass learning and still pass courses. Even when I was a student, there were past exam archives. It was called the archive. There was all the answers. And one student in your residence would maybe curate the archive. I've heard it's called Bibles. Then there was Chegg. Remember Chegg? I mean, we're not talking about Chegg right now, but I don't know if that was used much here, but that's a place where students could pay money and get solutions to exams. And. But I do think these current tools have really supercharged the possibility for being able to, let's just say, bypass learning. I think, I don't have time to talk in detail on this, but I think it is clear, and there are people doing this work. I think we're going to see more in-person assessments, at least at some point, where you have to stand and deliver, answer a question about your project, stand in front of your poster. Certainly found that we very much at UCT, University of Cape Town, we did good work on that. And yeah, and likewise also people are saying maybe more exam papers with pen and paper. Let's just see how this evolves, but I don't think we can be naive about assessment. We have to know that our assessments are valid. And here's just another quick flag, is distinguishing between formative and summative assessment. Formative is happening during the class, and it's that assessment that we're doing to help students make sure for themselves do they understand. It's the kind of learning behavior that is intrinsic to a deep approach to learning, is where you study and you go, yeah, I do understand this concept, okay, that's okay. Or, no, I still don't really understand that effective stress concept. So right, we are now at the point of tying together where I was trying to get to with this talk. And I want to share this quote because I'm thinking, why does this all matter? And here's a quote from some of my South African colleagues that I find very central. They're saying, students who haven't developed their own knowledge foundations will be increasingly marginalized in a world that paradoxically values human expertise more, not less, as AI advances. And then a final little pitch which really speaks to what's happening at this conference. A group of academics coming together to present their research and their scholarship on education and educational questions. And I really think this is important work. So firstly, if anyone ever stands up like me and say, I'm an educational expert and I can tell you what to do in your classroom, do not believe them. Because you are the experts in your discipline, geotechnical engineering. I'm giving you a few theories and so on that you can work with, but the deep work on how to do this in the discipline has to be done by people with that expertise. And I want to flag some options here. And if I go to the right hand there, I kind of had a look. I'm not sure about this glass full, glass half full metaphor that I'm playing with, but this I feel is about how much time you have and what is your academic role. So if your predominant research area is a very crucial part of geotechnical engineering and you have a huge lab and you also teach a second-year class, you don't have the time to run a whole program of engineering education research. But you can do some other things. If you like, I've been in a role through most of my career where I really have been expected predominantly to do education research and to a much lesser degree to do the technical research. That's fun. But I want to put in the middle something called scholarship of teaching and learning, which is the idea of doing a form of research that's very classroom-based And then on that left-hand side, I love the argument that all teachers should be scholars of education, scholars of their teaching, scholars of their students' learning. And so that's really a license to get going. Everybody's got a place where they can fit in. And I hope I've persuaded you today that these are questions that are quite compelling and they have answers that actually only you are able to develop within the discipline. So thank you for your time and attention. Just to acknowledge my support from my university's students, colleagues, and of course the support of the conference organizers. Thank you.
We have 5 minutes, a little less, for questions. So,
I said, "Oh my gosh," in your quiz, and so how do we handle this "oh my gosh" type of people in a less educated from the educational standpoint, general professors?
Thanks a lot. I think you're meaning this sort of, oh my gosh, students are going to cheat piece. Yeah. And I think there, as I just briefly touched on, how do we assess is really important. I also think, briefly, a curriculum challenge is we're in fields that are constantly growing and we tend to just stuff more and more content in. And that research project I was showing showed that makes it very hard for students to do a deep approach to learning because they just go, oh my gosh, there's so much content, I need to do something superficial. And then the risk, maybe I need to do some bypassing of my learning on some things. I think signaling the threshold concepts, I think working in the classroom with formative assessment, things that are happening in the class. I deliberately wanted to model, I'm sorry I didn't get my Slido. That's an app that's in PowerPoint, but there are other things like Mentimeter, stuff that happens in the class that helps students check their understanding. A completely no-tech thing that I've done all along. Here's an example, maybe that one on the left. Okay, everyone start working it out, and then I go, hey, let me see, what are you doing for him? Yeah, no, great. I told you, do you want students to get going and actually doing something? So I think we do have solutions, but we have to wake up and maybe activate them.
Well, I'm loud, I can yell. Thank you so much for the great presentation. Based on, you need to. All right, sorry. Thank you so much for the great presentation. Based on the research that you've seen, does it seem that encouraging use of AI to support learning in courses creates a bigger gap between higher performing and lower performing students, or it helps the lower performing students do better?
That's a great question. So quick answer, and I would want to go more in. A really difficult educational conundrum is almost anything you do to improve teaching and learning doesn't necessarily narrow a gap because all students will benefit and often, as you say, high-performing students even more. I do think, though, and particularly from my experience at the University of Cape Town, I think the real challenge for us is to be thinking across that gap in whatever context we're in. To make sure that the students who are maybe at the lower end of preparedness are able to. I think there's huge scope in these tools. So, I mean, it's a different technology, but we did research on what we called then lecture casting, just making recordings of the lectures online. And there's been hysteria all along. People are like, you can't do that, students will never attend classes. I'm telling you they did, but then they were able to go and rewind little bits, and particularly for students who were not first language English speakers, that had a huge impact. So I'm sorry, I can't give an easier answer. Definitely the gap will close because there's people who've researched that quite a lot, but I still think you can look at bringing up, yeah, okay, more to say. But yeah, you should be thinking about the gap. I'm pleased you raised that. Thanks.
We don't have time for another question, but the answer that Jenny gave about students replaying the video, we will have the opportunity to see Jenny's presentation again. She would also write a short, I don't know how should I call it, that will come to the SSMG bulletin. So this is the beginning of a discussion, and you're going to share the slides,
Okay,
right?
yeah.
Okay, so thank you very much.